let us start the thing. So if what we have covered in the last class, that we have discussed the problems, and like we have also see that how to found the formula of a compound if we have given the different types of distributions are there. That is what we have seen till now, right? And also like we have also seen the packing in two dimension, right? We have seen the packing in two
Okay.
dimension, how to do the packing is in the two dimension. So okay, yeah, so right now in this class we have to start the packing in three dimensions. Okay, so let us start with the packing in, like how to do the packing in three dimension. We will start with that. Okay, so let us start. I'm just removing these pages because this will be not for use. So show this. You are clear with the like how to find the formula of the compound. This is clear, right? There is a no doubt in
Okay.
it. Okay. So let us start with this. So as we have seen the packing in like 2D, so let us see the packing in 3D. Okay. Close packing in 3D. Okay. Close packing in 3D. In 3D, we are going to discuss that how we are going to do the close packing. If you remember in square, like in 2D, we have two types of packings we are doing, right? One is called as a like we have done a one. If you remember, we have done two types of packing. One is called as a square. Square, we have a square geometry. We have got this thing that is SCP square close packing we have done, and another one we have done is the hexagonal. Like we are gauging a hexagonal ring, so that is called as a hexagonal close packing, that is SCP packing. So these type of the two packings which we have done in the 2D only. We have completed these two packing, right, in 2D. Now in 3D we have to see these type of, now in 3D we have to discuss that what are the different types of packings we have in 3D. So let us start with this. In 3D, whatever the packing we are going to do, we are going to use the 2D packing only. Okay, we see, like if you remember, we have started the 2D packing by using 1D packing. First we have done the 1D packing, then after that 2D packing is based on the 1D packing. Similarly, the 3D packing is going to be also based on the 2D packing. So from 2D packing we will do the 3D packing. And now how we are going to do it, let us see that, and let us try to understand it. So basically, if you remember, we have two cases here in 2D. Case number one, 3D packing. First, we will use by using SCP, that is square close packing. Okay, first we have discussed about the square close packing. In square close packing, if you remember, we have seen that we are first placing the atom in x direction, then we are placing the other first we are placing a layer A, then we are placing another layer A just below the layer A, and when we are taking the unit cell, we are getting a square unit cell. If you are remember, this type of packing we have done in SCP. Okay, square close packing in 2D. Here it is. Yes, if this is the square close packing in 2D. Now in 3D, what we are going to do, see, in 2D means we are putting the atoms in only x and y plane, right? We are putting the atoms only in the horizontal plane. Now in 3D means we are going to put the atom in the z axis also, means it will be in the horizontal as well as in the vertical plane. Okay, both that type of things will be there. So how it is going to be happen, let us see that. So basically we will first place the same thing whatever we have done in SCP. Okay, we will first place the layer A atom. So suppose this is my layer A, so I will place the layer A atom. Okay, just place the layer A atom. Suppose this is my layer A. It is similar to, first I will make the, first I am making my, uh, wow, this is something good. Yeah, this is my square close packing. If you will find the unit cell, you will get a square unit cell that I have told you in this class. In the last class, we have discussed this. Now, what is the new thing is going to be, we are going to do? That is new thing is this. We are going to place the same layer. Okay, the same layer will be placed. Oh, sorry. Sorry. This is same layer will be placed, and the size of the atom will be also same. Okay, it's look different because it should be visible to you, that's why I'm making slight different, but the size of the atom will be also same. It is exactly same size. Okay, but for you I am drawing it slightly that you can able to see it, but it is exactly same. Okay, exactly same type we are going to place. So what we are doing, let me explain you what we are doing basically. Just first let me draw this. Actually, what we have done, we have first taken this one layer, that is SCP. Okay, if you remember, we have taken the SCP 2D layer, and then we have placed the another SCP 2D layer above to it. Okay, means we are whatever the layer in down we have, the same layer we are keeping above over it. So that is called as a 3D close packing by using SCP. Okay, so what we are doing, we are placing the same layer above the another layer. That is only the meaning of this. We are placing the same layer over the another layer. Okay, so similarly what you will see in if you try to observe this, what you will see, like this. Okay, it will go like this. Yes, it will go like this. Okay, like this. If you want, you can draw from here like this. Okay, so what we are getting, if you try to understand, see, this is our first layer in horizontal plane. I have placed layer A, then layer A. Then what I did in the above, just I placed that same layer, and now they are not they now these are spheres. Remember, these are spheres now because it is in 3D, right? In 2D, I have told you that you have to consider it as a disk. In 3D, it is act as a spheres. So now it is a sphere. So it is like this. So we are now moving in this direction also, in this direction also, in this direction also, in this direction, in all directions we are moving. So that is called as a 3D close packing by using square close packing. Now if you try to find the unit cell, what type of unit cell you will get here? If you try to get the unit cell, what type of unit cell you will observe? You will see this thing, right? If you try to draw the unit cell, what you will see? From here you will cut this, right? To get the unit cell, you will cut like this. When you cut and remove this portion, when you cut and remove this portion and keep it in front of you, suppose, then what you will get? Try to imagine and tell me. If I remove that portion and give it to you, then what you will see? What type of geometry it is? Remember, we have A, B, C, D, then E. E is behind atom, okay? Then F, then G, then H. So now if you try to observe this, what it will look like?
Cube.
Yes, it is a cube, and it is a cube, and which type of unit cell it is? It is a which type of unit cell? It is a cube, but which type of unit cell? If you see in this unit cell, we have atoms at the corner. If you try to imagine, we have a unit cell where the atoms are at the corner and they are touching each other. The atoms at the corner, they are touching each other. Which type of unit cell it is? Which type of unit cell the atoms at the corner touch each other? It is simple cubic unit cell, SCC. This is simple cubic unit cell. Okay, it is a simple cubic unit cell. So if you absorb this unit cell, it will be look like a simple cubic unit cell. Now we know all the properties of simple cubic unit cell, right? So let us write. So there is nothing to remember new about it because you know everything about simple cubic unit cell. So what is first thing? What is Z effective for simple cubic unit cell? What is the Z effective? We know.
One.
What is the Z effective?
Sir, 1.
Yeah, Z effective is 1. What is the coordination number for SCC, simple cubic unit cell?
6.
Coordination number is 6. Okay, what is the packing fraction for simple cubic unit cell? What is the packing fraction for simple cubic unit cell?
52.4.
Yeah, 52.4%. So what will be the percentage voids will be there? How much? That is 100 minus 52.4%. That is equal to how much? How much will we get? 47.6%, right? And
Yes,
here
sir.
what we have observed that it is a looking like a this is a nothing but a simple cubic unit cell. And if I ask you the relation between A and R, then what you can say? Relation between A and R?
2R is equal to A.
A is equal to
2R.
2R. Simple. So there is nothing we have to remember new. All things we have covered. Because when we observe the unit cell, we have find that it is similar to a simple cubic unit cell. So there is nothing to remember new. Okay, it is normal. Clear? Now let us move to the another thing. See, this we have tried with simple. This we have this type of packing in 3D we got when we used a square close packing in 2D. By using the square close packing in 2D, we are getting a simple cubic unit cell in 3D. Now let us use the hexagonal close packing in 2D. If we remember, we have placed the in hexagonal close packing in 2D, and let us try to analyze what type of unit cell we are getting in 3D. So case 2 is now SCP, that is hexagonal unit, or we can say (3D) close packing by using SCP-2D. Means I am going to use my SCP-2D to do the hexagon, to do the 3D packing. So let us use this. Okay, so let us try this. It's difficult to draw, but okay. You draw layer A same as SCP-2D. Okay, as we have drawn, same type we have to draw again. I'm not drawing too much because it will take very long time to draw. Okay, I will draw it little fast. Okay. Then where the second atom is placed? Second layer is placed between the gap of the two atom, right? In SCP-2D, the second layer is placed between the gap of the two atom, right?
Yes, sir.
Yeah, so just place this atom. Yes. Now this one. Yeah. And now this one. Remember, both the layers are different. Why? Because this atom is placed on the gap between the two atoms. So this is my layer A, layer B. So if, and similarly we can draw layer C also. Then if we will take, then we will get a what? We will get a hexagon. If let me show you once. If you remember,
Okay.
uh, this is the what I am talking about. This thing we have discussed, right? So this is what I am saying. If you place one more layer below this, let me place only one more layer. Okay, let me use some different color. So, or we can do one. We can just copy this, right? Is that okay? Yeah. So this is the thing. This is my SCP-2D. If you have observed, if I draw, like I take this, I will draw, I will get a one hexagon. Now this is my layer A, layer B, layer C in 2D. This is layer A. If you remember, this is my layer A and this is my layer B. Two layers we have. Now what is the third layer, where the third layer we are going to place? Okay. If you try to see, we have to place, now see, we have done the packing in the horizontal plane. Now we have to do the another packing in the vertical direction above. Now we have to move upward like this. Now the question is that where the third atom has to be placed. So now the third atom is going to be placed on the gap which is present between the layer A and the layer B. If you see in the layer A and the layer B, we have a gap. Here we have a gap, here gap is there, gap is there, gap is there, that gap is there. These all are gaps. These all called as a whites. Whites means gap. Okay, these all are called as a whites. So we are going to place these atoms in the whites. Okay, we are going to place these atoms in these voids. Means we are going to place the atoms because our aim is to only fill these gaps. Okay, our aim is always to fill these gaps. Our aim is always to see why we are doing this packing and all, because we want to fill these gaps. So our next atom is going to be placed where? It is going to be placed on the gaps only. So we are going to place this atom on the gaps. So this is our first atom. Let me like make it properly. Okay, so it should look perfect, right? Like this. This is our first atom. Okay. I don't know whether it is diagram look proper or not, because it's slightly difficult to draw it properly. I think I should bring the diagram. Are you able to understand what I am trying to say?
Yes, sir.
Like how this atom is getting placed. I don't have a 3D model right now. It is in my room. Like, otherwise, it will be more clear to you. Okay, this is how, like we have placed the another layer in layer C, which is in upward direction over the gap which is formed between the layer A and the layer B. I hope you are able to get this point, like
Yes, sir.
how we are placing the atom. Okay, so let me place. So similarly, this atom will be placed like this. Okay, and this atom will be placed like this. Okay, this atom will be placed like this. So okay, so we are placing the second layer over the voids of the over the voids that is formed in the first ground layer. Now if you see properly, there is another new gap is formed. This gaps. Okay, these gaps, you can see there is a one more new gap is formed, not this like these gap, like gap which is surrounding 1 3 6 atoms are surrounded by this gap. These gaps are there, these gaps, there is a new gaps are formed, and these are called as a octahedral void. We will discuss that also, but leave it now. Now what we are going to place, what is our next layer? See, we have placed layer scp2d in ground, then we have placed the another layer which is in the gap of the ground layer. Okay, now we have to place the another more layer. Now our what is the going to be our next layer? Where our next layer is going to be placed? Now that is a question. What is our next layer? What is my next layer? What is my next layer?
Sir, in between the gaps of these atoms.
Yeah, we are going to place this. Now the next layer will be placed here in this gap. Are you getting my point? Are you
Yes,
able,
sir.
are you able to understand like how we are placing, like how the atoms are getting placed? See, first layer is this, second layer we have this. Now the third layer will be the gap of these gaps. We are going to place the atoms in these gaps. Are you
Yes,
getting
sir.
my point? So this is how we are going to place the atom. So our next layer will be, let me change the color, and it will be like yellow. Okay, so we are going to place the atom, next atom, sorry. So this is our next atom which is going to be placed like this. We are going to place our next atom here. Okay, like this. This is going to our next atom. Similarly, another like this, we have another atom. So are you getting my point? Like how we are placing the atom? I hope
Yes,
it
sir.
because this image look very clumsy, but try to understand how we have placed it. That's why it's very important. By image you can't understand. You have to understand. First is scp2d. Okay, then we have another layer which is placed over the voids of the first layer, and then we have a third layer. Third layer is nothing, the voids which is formed by the placing of these two layers. Okay, let me write it. Okay, then it will be clear. Let me write it for you. So we have
Okay.
first layer. We are, let us discuss about the first layer. So first layer is a layer A. Layer A means this layer I am talking about. This layer. Okay. This layer. This layer is layer A is a SCP2D spheres. They are SCP2D spheres. Okay. Layer 2. That is layer B. Okay. Layer B don't resemble like this. Layer B means I am resembling this thing. This white layer, that is layer B. Okay, similarly then we have a layer C. Okay, now let us write the point what we are writing. Yeah, layer B is SCP2D spheres placed over the voids of the layer A. Okay, so layer B is placed over the voids of the layer A. Now the next point, that is layer C. Layer C is going to be placed on the voids which is formed by the layer A and the layer B. Okay, so layer C is a SCP 2D sphere placed over voids of layer A and B. I hope now it is clear. First we have a layer SCP2D, then we have a layer B which is placed over the voids of a layer A, and the next we have a layer C which is placed that is void which is placed over the void that is formed by the layer A and the layer B. So this is the packing in 3D we are doing. So if you see properly, you will understand. See, in the first layer, let us see, if you try to get the unit cell, that is like difficult, I won't draw here. But if you see in layer A, we have three layers, right? We have layer A, then we have layer B, then we have layer C. So if you see in one unit cell, in layer A, we have a how much atom? 6 atom.
Yes, sir.
Or yeah, we have a 6 atoms, right? In layer A, we have a 6 atoms, and layer B, we will have also have a 1 minute. If I take as a unit cell, I will cut like this, right? No, just wait for a minute. 1 minute. Okay. Yeah. No. Actually, if I cut this as a unit cell, na, like in the previous case, if I have taken a unit cell, I am getting is a simple cubic unit cell. Similarly, here also, if you take one unit cell from here, the unit cell, okay, then what you will get? You will get a FCC unit cell. Okay, FCC unit cell. FCC unit cell, we have learned about the FCC unit cell. So in FCC unit cell, what we have learned, on every face we have one atom, right? On an every corners we have an atom. In face centered unit cell, we have atoms at the faces on the face center, and we have atoms at the corner. So if you see that, this is nothing but a one of the face which has one atom, then we have atoms at the corner and one atom at the another face. So when you rotate it by 180-degree, when you cut it and rotate by 90-degree, not 180-degree. If you cut a one unit cell and rotate by 190-degree, you will get a called as a FCC unit cell. You will get a FCC unit cell, and for FCC unit cell, the layer A will have a one atom, layer B will have a 6 atom, and layer C will also have a 6 atom. This is the scenario we will have. Okay, so this is layer A, layer B, layer C, and the unit cell is FCC. If my unit cell is FCC and these are the layers, then I can write the other property also. And what is the other properties I can write? The next property I can write is the Z effective. Z effective for FCC unit cell is how much? 4? Yes or no?
Yes, sir.
So Z effective will be 4. Then coordination number of the FCC unit cell is how much? What is the coordination number? What is the coordination number of FCC unit cell? One atom is touched by how?
Sir, can you hear me?
Yeah.
Is it 4?
No, it's not. Coordination number is not 4, it is 12, right? In FCC unit cell, the coordination number is 12. One atom is touched by the 12 atoms. If I have told you, see, 4 will be the corners, one will be this ceiling, one will be this ceiling, one will be this ceiling, one will be this ceiling. So 4 here and 4 just opposite of this room. So four faces, total 8 faces will be touching and 4 corners will be touching. So total we have how many coordination numbers? 12 is the coordination. Okay, the fourth thing is that packing fraction. So if you remember, the packing fraction we have got is 74%, and percentage void for this is how much?
100 minus 74.
174. That is how much? I think 26%, right?
Yes, sir.
Now another thing, relation between A and R. Relation between A and R. So what is the relation we have got? 2R is equal to root 2.
Root 2 A by 2.
These are the important results we have in the FCC unit cell. I hope it is clear. So this is how we do the packing in 3D. Now we have seen only the two cases. Now there is a one more case is there. What is the one more case? See, what we have done in this type of packing. In this type of packing, we have placed the layer A, no problem. When we have gone to place the layer B, we are placing the layer B in the voids of the layer A, right? We are placing the layer B in the voids that is formed by the layer A, the bottommost layer, right? Are you
Yes,
getting my
sir.
point? Now what we are going to do, we are going to place the second layer just over the first layer. Means my layer A and layer B is going to be same. What I'm trying to say, it is a same as a square. If you remember, in 3D we have
Yes, sir.
this one we have done. See this one. Now we are going to use this one to make another new case. This one we have done, right? It is in
Yes,
3D
sir.
3D close packing only. The unit cell we got is a simple cubic unit cell. Now we are going to use this to make another one, another type of a packing. Let us examine that. Okay.
Okay, sir.
1 minute. What has happened? With the main installation. So what we are going to do? The case 3, SCP from SCP 3D. SCP 2D. Okay. SCP 2D. We are going to do SCP packing. It's a like you can write here packing. SCP close packing. Close packing. Sorry. SCP close packing by using SCP-2D. Again, we are going to use SCP-2D only, but we are going to use in 3D manner. Sorry. Just a second. Yeah. So we are going to do that. Let us see how we are going to place those items. So this is my again layer A. Okay. Same layer. This is my layer A. How we are going to do this? Let us see. So suppose this is my layer A. Okay. Now this is my another layer B. Oh, so not layer B. This I am placing my layer A. So let us do it first. Okay, clear. Now we have 1 minute. We have to use SCP-2D, right? Okay. So we have to do slide change in this. Wait. This one I place it below here. First, we will make again SCP-2D. Let me make SCP-2D first, complete this. This is my SCP-2D, right? After that, what we have to do? Again, we have to place, let me place one more layer for you. What is happening? Let me, yes. See why I am drawing this so that you can understand like how the exactly the layers are placed and it will be clear to you. It's not exactly up to the scale, but I hope you can understand.
Yes, sir.
Okay, yeah, leave it. So this is our SCP-2D layer which we have seen. Now what we have to do, we have to place the another layer. Now the another layer, how it is going to be? It is going to be exactly same as that layer. Exactly same layer we are going to place it over above it. Okay, exactly same layer. There will be no difference. We are not going to do any difference. We are going to place exactly same layer over the other, like this. Is it possible to? No, it's not possible. And I'm just placing little small so that you can see the difference.
Okay, sir.
Yeah. So like this, we will place all the atoms. So let us place it first. See, this chapter is almost finished only. If I just complete this close packing, then nothing is left. Because this is a time taking portion because it has to be explained very properly. Yeah. Okay. So this is our layer A and this is our layer B. So let me write this also for you. This is our layer A, and the another one which is placed is layer B, exactly same as layer A. So you can write it as layer A and layer A. So both are layer A only, both the layers are same. Now how to place the third layer? Third layer we are going to place over the whites, this whites which is formed, okay, this whites. So our third layer will be like this. Let me take another color, and this is going to be my third layer. Yeah. So this is my third layer, and we are going to place the atoms like this. In the gap of the first two layers, we are going to place the atoms. Okay, and the other layer will be placed like this, because then only it will fill this gap, right? So like this, we have placed all the atoms like this. Okay, so like this we are placing our another layer. This we will name as layer B. So I hope now it is clear how we are placing the atom. Layer A, layer A, layer B, like this. So you let me write this for you also. So our first layer, if you see, first layer is simply the SCP-2D layer. Okay, it is a layer A. That is, I'm talking about first layer is a SCP-2D layer. Okay, first layer is a SCP-2D layer. Second layer, second layer, it is again A. It is same as that of A only. Okay, like basically my another layer is exactly the same as the like previous layer. Okay, there is no difference in the okay layer A only. It is placed over the layer A. Okay, it is placed over the layer A. Now our next layer is I think there is some mistake we are doing. 1 minute. I think there is some mistake. Just let me check once. Layer A is there. Then we are placing layer B. Okay, okay, okay. 1 minute. There is a one mistake. Please don't note it. Just 1 minute. Okay, okay, okay. Sorry, one mistake is there. Actually, what we are doing, we are placing the layer A. Then this is my layer B. Okay, this is my layer B, and then another. This is again my layer A. That is the mistake is there. So second layer is layer B. That is where atoms are placed in whites of layer A. Means what is happening? And third is layer is same as layer A. Same as layer A. So what we are doing, make it clear. See, in this, what we are doing, we are placing the layer A, that is SCP-2D. Then we are placing the another layer, which is in the voids of the layer A. and then we are placing third layer which is in the voids of both layer A and layer B. That is this thing. Here what we are doing, here first we are placing the layer A, then we are placing the layer B which is in the void of layer A and layer A. That is the same thing. These both are up to layer B, up to layer B, they both are same. In here also we are placing the layer A and the layer B is the void of the layer A. Similarly here also we are doing the same thing. Okay, I have mistaken the layers. Okay, first we are placing the layer A, then we are placing the layer B which is in placed in the voids of a layer A. Now the third layer we are changing, there the third layer in the last case we are placing the third layer in the voids of the first and second layer. Okay, but here we are placing the third layer same as that of first layer. That is a difference. Only there is a difference of the last layer. The last layer there it is placed in the voids, then these voids. Okay, but here the third layer is placed over this. Okay, which I have told earlier as a second layer. A second layer, that is not a second layer, it's a layer, it is a layer third. Basically this is layer third. Okay, so what is this? Basically we have layer A, then we have a layer B which is placed in the voids of the layer A, which is same as the previous case, and then the layer C which is placed same as that layer A. Are you getting my point?
Yes,
How
sir.
it is now? Sorry
Yes,
for that mistake. Basically, it's happened. Now, if you try to see the important points in first in layer A, we have basically three layer. Let me write it here. Okay, layer we have. Sorry, here I can write. First we have layer A. Sorry, layer A. Then we have layer B. Then we have layer C. So what is in layer A? What will be there? See, in layer A, if you take the unit cell, you will get 7 atoms. Okay, 7 atoms you will get. How 7 atoms? 6 atoms at the corner of the hexagon and one at the body center. So you will get the 7 atom. In middle, if you will see in layer B, you will get 3 atoms at the body center. This 3 atom will be at the body center. And then we have a layer C. Again, we have a 7 atom. Again we have a 7 atom. So this is called as a SCP unit cell. This type of unit cell is a SCP unit cell, and this we haven't discussed till now. Okay, this is a SCP unit cell. We have to discuss this in 3D. In 3D we are getting. So we have to discuss this unit cell. Let us discuss about this unit cell in detail. And what is first? Let me draw the like diagram for this. Then you will able to see that how exactly it look like. Okay. Oh, so I have to draw hexagon. 1 minute. 1 minute. There is a way to draw here. Mm, let me check. This is able to draw or not. I think it will draw. Okay. Let me draw it properly. Not looking proper. See, we have to draw the hexagon. Basically, how this geometry look like. I want to just make it clear to you so that you can understand how the atoms are placed. Just give me 1 second. Let me draw this. Because sometimes they ask some questions where you should know how to draw the diagram. Oh, wait a minute. I can copy this. So this is my bottom layer and this is my top layer. If I join this like this, then we have this thing. It's not look perfect, I guess. It's not look perfect, right? uh, how I will do? Okay, let me do this one with this, and this one with this. It's not look perfect. Okay, I have to draw this. No other option. Is it possible to? It won't look perfect. We have to draw only. Okay, it's not coming. What I will do? Uh, Let me try to put it. Okay, let's try to cooperate with this because diagrams are not coming perfectly. So this is basically exactly how it look like. Like I will try to explain it properly so that I hope you are able to understand the diagram. Is it able to?
Sir,
Basically, there are six faces are there. One top, one bottom is there. And how the atoms are placed, let me make that also clear to you. One atom at this corner, 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 one atom at this corner. Sorry. One atom at this corner, one atom at this corner, this corner, this corner. Okay, then one atom at this face, one atom at this face center. Similarly, we have another atom at this face center. Now, if you see at the like in the body center, I have told that there are three atoms are there. So how they are three atoms? In body center, we have three atoms like this, one atom like this. Okay. Then we have another atom like this, and then we have another atom like this. And this I have drawn far, like, but in reality, they all are touching each other. Okay. First, we have a 7-layer atom at the verb, 3-layer atom in the middle, and then 7-layer atom. So it is look like a hexagonal shape, hexagonal geometry. So this is
okay.
hexagonal close packing. In hexagonal close packing, this is what I mentioned as layer A. This is my layer A, which I told you. This is my layer B, which I told, and this is again my layer A. This is again my layer A. So this is how the atoms are placed in a SCP unit cell. If you cut this one unit cell and you will take out, you will see it like this. Okay. So if I ask you the important things about this unit cell, because it is a new unit cell, right? We haven't seen this unit cell till now. So our first question will be, we have to calculate everything for this. So our first question will be Z effective. So if I see the Z effective, see there are the atoms at the corner. How many corners are there? 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12. We have 12 corners, means 12 atoms. How much contribution will be there? If you see, it is a hexagon geometry. This angle will be how much? This angle for a hexagon, what is the angle between the two lines for a hexagon? It is 30 degree. It is
Yes,
30,
sir.
360, it's a 60 degree, not 30 degree, it's a 60 degree. So the contribution for this will be 1 by 6 at the corner. Remember, it is 1 by 6 contribution is there for SCP. Okay, because there are 6 corners are there na, 1 2 3 4 5 6. So at one corner 1 by 6 contribution, total 6 corners
Yes,
are there,
sir.
one corner 1 by 6. Similarly in cube we have 8 like we have a 8 corners, yeah, we have 8 corners, so we have contribution is 1 by 8. Similarly 6 corner on one side, so we have contribution as 1 by 6. Similarly 1 by 6 plus how many atoms at the face? 2 atom at the face, and we know what is the contribution, 1 by 2. Similarly, how many atoms at the body center? 3 atoms at the body center, the contribution is 1. Okay, so this is at the body center, this is at the face center. Sorry, what is happening? Yeah, this is at the face center and this is at the corners. So if you calculate the Z effective, how much you will get? Say this is 1, 4, 1, 5, 5, 6, 7. So the Z effective is, no, how much is 3, 4, 5, 6, sorry, 6, not 7. This Z effective will be 6. Now what is the coordination number? How many atoms are touching one atom? How many atoms are touching the one atom? Tell me, how many atoms are touching the one atom? If I see one atom, how many atoms are there which are touching each other? How many
Sir,
atoms? Yeah, tell.
is it 6?
Let us see this atom. Okay. See, this atom will be touched by all these corner atoms, right? Is it okay?
Yes, sir.
This atom will be touched by all the corner atoms. Clear?
Yes, sir.
Now, this atom will be also touched by these 3 atoms.
Yes, sir.
So, this is 6. 6 plus 3 is 9, right?
Yes, sir.
Now, this same layer is going down also, up also, because it is going from here to here. Okay, it is not like that. This is a one unit cell, and this thing is repeated continuously, right?
Yes,
So,
sir.
this is layer A, then layer B, then layer A, then again layer B, right? So similarly, below this we have a one layer B must be there, right?
Yes, sir.
So this is my how much? This is my 6 atoms will be here. 3 atoms is above and 3 atoms will be below, right?
Yes, sir.
So how many total atoms will be there?
12.
So total atoms will be 12. So how many total atoms? The total atom will be 12. Okay. The total number of atoms which are touching one atom is 12 atom.
Yes,
Clear?
sir.
Clear?
Yes, sir.
Okay. Let me write this also. 6 plus 3 plus 3. Basically 6 is corner atoms. Okay. 6 is corner atom. 3 atom is body center. Body center, how you write? Between layer A and below layer A. You can write below layer A. Okay, this is like this. Contribution is like this. This you are adding, you are getting 12. Now, next thing is that if I ask you, this is a question which is from JEE Advanced. They have asked this question. They have just JEE Advanced is nothing. They just flip small. Okay, small. They just make a small changes. What they have asked? They have asked what is the coordination number for topmost layer? For topmost layer. See this. There must be some topmost layer, right? This layer is repeated. There must be some topmost layer. At the topmost layer, they have asked you what is the coordination number. At the topmost layer, what is the coordination number?
9.
Yes, very good. Very, very good. Coordination number is 9 because At the topmost layer, we have not this layer, right? So we have only corners and this atom, obviously, because topmost layer is not there. So obviously it will be 9 only, right? Very good. So this is the different things. Now the next thing is packing efficiency. Next thing is left is packing efficiency. So what is the packing efficiency? Z effective into volume of the atoms upon volume of the unit cell into 100, right? See, Z effective we know this is how much, what, 6, right? Volume of the atom we know 4 by 3 pi r cube. Okay. What is the volume of the unit cell? Means volume of this geometry. Oh, one more thing. A is equal to how much? 2r, right? These two atoms are touching.
Okay.
This is A. So this is equal to 2r. My question is not this. My question is, what is the volume of the atom? How will you find the volume? How will you calculate the volume? That is my question. How will you calculate the volume? How will you calculate the volume for this geometry? For this geometry, how will you calculate the volume? What is the way to calculate the volume for this? Can anyone tell me? Like how we will calculate the volume? Can you tell me, like, see, this is mathematics complete. If you calculate this height, okay, if you calculate this height, which height? This height, okay. If you calculate this height, okay, there is a complete derivation is there. The height is almost, it is coming 4 root 2 by 3, I think A. 4 root 2 by 3 A, or not A, it's R. 4 root 2 by 3 R. Okay. This height is 4 root 2 by 3 R. This is the height you will get. Okay. I know the height. If I know the area, I can find the volume, because I know my volume of any 3D geometry is area into height. Okay. So if I know, see, height I know that is 4 root over 2 by 3 into R. I want to know the area. How to find the area? See, if you try to understand, we have a hexagon, right? We have a hexagon.
Yes, sir.
Okay. We have a hexagon, right? Like this. If you divide it into equal parts and all the sides are equal, this is A, this is A. So if you divide into a equal part, it will behave this is a equilateral triangle, and there are 6 equilateral triangle will be there. So area will be 6 into root 3 by 4 into A square. So we know the area. Similarly, we know the height. Just put it there. So it will be how much? 6 into root 3 by 4 into A square, and we know the relation between A and R. A is equal to 2R. Just put everything and you calculate the volume. You will get how much? 24 root 2 into R cube. Okay, 24 root 2 into R cube. This is the volume you get. Just put it here. 24 root 2 into R cube into 100. This R cube will be cancel out. This 24 will be cancel out. This will be pi by root 2 into 3 into 100. Do you remember where we got this expression? This expression is, we have got somewhere else also. Where we have got this expression? This is the expression we got in FCC. FCC. So this is 74%. And what is the void? Percentage void. Percentage voids will be 100 minus 4%. That is 26%. So what we have understand from this? The thing we have understand is that maximum efficiency we can get is the 74%. We can't get more than that efficiency. That is not possible in reality.
Yes, sir.
It is not possible to get a maximum efficiency of more than 74%. If you take any type of packing, any type of unit cell, we can't get more than that. because that is a maximum percentage, and that is what we have calculated. So this is the maximum percentage we have got for SCP. But what is the benefit is there in this type of packing? The benefit is that we are using hexagonal or structure. Hexagonal has a one property, that it has a like very high pack. Like if we want to pack, suppose I take uh like, why we prefer like hexagonal, because suppose we are attaching the cubes. Okay, this is not important. Suppose you are attaching a cube, so there are the atoms. When you touch the atoms, there will be some gap will be left, they will not touch each other properly. Okay, there will be some small gaps will be there, that we will discuss in defects. What are the defects in the solid? That will be there's some gap will be there, but for to prevent that gap, we are using SCP lattice. This is called as the SCP lattice, hexagonal close pack lattice, where we are using SCP unit cells. Clear?
Yes, sir.
So these are the different types of close packings we have seen. I like, first we have started with the 1D, then we have moved to 2D. In 2D we have seen the two types of packing by using the square close packing, where we got the unit cell as a square unit cell. Then we have moved to the hexagonal close packing, where we got the unit cell as the hexagonal unit cell. Then we have moved to the another type of packing, that is called as a packing in 3D. We have done the packing in 3D by using the square close packing and by using the hexagonal close packing of 2D. When we have done the square close packing, we have got a simple cubic unit cell, that is SCC. Then after that, we move to the hexagonal close packing by using hexagonal 2D, case 2 in 3D. Then we have got a FCC unit cell. And the last case which we have done right now is we have used the hexagonal 2D only, but we have changed a one difference, that is we have changed the third layer. In spite of placing in the voids of the layer which is formed by the first layer and the second layer, we have placed same as that of first layer, we have got another type of unit cell, that is called as a SCP unit cell. And the SCP unit cell, we have calculated everything. We have got that its packing fraction is 76%. Everything is same as that of FCC. Only the difference is the Z effective and the coordination number is more. Clear? So this is complete about the close packing, and like there is no concept is left that is not present, that I haven't completed. Everything is completed in the close packing. Now no question can be go beyond this, and in paper they won't ask you that much also. They will ask you the direct result. What is the packing fraction in the HCP lattice? What is the percentage void in the HCP lattice? What is the relation between A and R? They don't ask this thing. What is the volume? What is the area? They don't know. Never they have asked you this height. This height has been never asked, but I have told you so that you can have an idea. Okay, now let us move to our next topic, that is called as a that is called as a which is a very important topic, is the voids. What are the different types of voids we are there? See, when whatever types of packing we are doing, it is very clear that we will always get a void. There will be no free space will be, like there will be some free space will be left. Okay, we cannot cover all the gaps, so there will be some free space, so that is called as a voids. The voids are nothing, they are the free space. Okay, our next topic is voids. Voids are nothing, the free space or the gaps in the lattice. Okay, the gaps in the lattice between the atoms or whatever you can say, that is called as the voids. What are the different types of voids are there? Types of voids. So if I see the types of voids, the first void is triangular void. First type of void we have is triangular. How the triangular void is formed? Anyone remember where we have seen the triangular void? See, it is like this. First, let me tell you how it is formed. Okay, you take one atom, take another atom also, take the same atom, place this atom like this, and then place the another atom. Okay, this is this thing. This thing is a triangular void. Triangular void. If you remember where it is formed, where the triangular void is formed,
Hexagonal closed packing.
If you remember, see, first thing, it will be not formed in the 3D because it is a 2D type of void. It is not in 3D voids. You can say it is formed where? Um, Let me show you. Because 3D hai na, this is a 3D void. It can't be formed here. See, it is formed in the hexagonal closed packing in 2D, not in 3D. Okay, hexagonal closed packing there, but it is in 2D. See, three atoms, this void, three atoms, this void, this void, this void, this void, this void, this void. All are what type of void? They are
Triangular void.
so it is in XCP2D. So this type of question they ask multiple time. Okay, so it is formed in where you will see that you take SCP2D, you will get this triangular void. If I ask you what is the coordination number here, like how much atoms surrounding this void, how much atoms surrounding this void, how much atoms surrounding this void?
6.
Three atoms are there. No. Just coordination number means how much atoms, by which number of atom it is this void is formed. Three atoms. It need one atom to found this na. So the coordination number will be 3 here. Okay. Now similarly, another type of void is we have another void is called as a tetrahedral void. Tetrahedral void. Now what is tetrahedral void? Let us see. See, I am taking this void, this thing. Let's take this thing, just keep it here. And what I am doing, I am placing a one atom above these three atoms like this. Three atoms in one plane, one atom is just above it like this. Okay, so this is called as a tetrahedral void. So if you see, there is a void is there which is seen from the inside, this void. Now it is a tetrahedral void. Tetrahedral void. What is the coordination number will be here? What is the coordination number?
4.
Coordination number is 4. Where it is formed? If you remember, it is formed in FCC unit cell. There also we have a one atom at the face center and 4 atoms at the corner. So if you remember, let me show you here where it is. Yes, this is, see, 3 atoms in one layer, one atom is placing just above the other layer B. Okay, so this void we are seeing that is called as a tetrahedral void. Now because now it is, now the fourth atom is also placed over it, so it is called as a tetrahedral void. Are you getting my point? This is the FCC unit cell in 3D. Okay, FCC unit cell in 3D. So we are getting tetrahedral void. SCP unit cell. In SCP unit cell, we also get this tetrahedral void. Let us see here. See, this is my SCP unit cell. First layer, second layer is placed over the void of the first layer. Again, we are getting a tetrahedral void, this void. Clear? So these are the places where we get a tetrahedral void. And what is the coordination number? 4th. Okay. Next type of void is octahedral void. First tell me, what do you mean by octahedral? Its meaning is 6 atom or 8 atom, because there is a big confusion between this. 6 atom or 8 atom?
So 8.
No, its meaning is 6 atom. Octahedral doesn't mean it is a 8 atom. Okay,
Okay.
it's a 6 atom. if you remember, if you are going through a chemical bonding, in chemical bonding we see six atoms, but the number of bonds are, sorry, see eight atoms, but the number of bond is six only. So it is the six, it doesn't mean eight. Okay, remember it is a six.
Okay.
Now how it is placed, let us see that. That is important, how it is placed. So it is placed like this. Suppose this is my one atom, and I will take this. Okay, this is my another atom will be there, and this is my another atom will be there. Okay, so this is my one layer. This is a, what type of void we are getting here? Triangular void. Now what I am going to do, uh, now I will take this and flip this, and I will place this whole thing over this. Are you getting how what happened now?
Yes, sir.
I am taking that one layer, I am taking that one layer, triangular void. I have just taken that triangular void and I have flipped it. Okay. And I have placed that layer above this. So that is called as a octahedral void. So you can see six layer in the one layer and six layer is just above the other layer. So that void is called as a, octahedral void. So this is what we are seeing here. This void is octahedral void. Hedral void. Okay, if I ask you coordination number, six atoms are there, so coordination number is six. Where it is formed? Can you tell me where it is formed? It is formed in the FCC unit cell. It is formed in the SCP unit cell. Let me show you how, where it is exactly. Let us see here, SCP unit cell. See, what is the condition? Three layers should be in one atom and three layers in should be another atom. See this, 1, 2, 3, one layer, 1, 2, 3, opposite manner. So this void is a octahedral void in SCP unit cell. Similarly, in FCC unit cell, how it is there? Come here. See, 1, 2, 3, one atom, pink color, one atom, then white color, 1, 2, 3, opposite star, white color. So this is a octahedral void. Are you getting my point?
Yes, sir.
So this is our octahedral void. Now our next void is cubical void. Cubical, one more second. 16, 18. Yeah, cubical void. So what is the cubical void? In cubical void, what is going to be happen? We are going to place the atom like this. Suppose this is a one atom. This is another atom. This is another atom, and this we have the another one. Okay, so this is the four atom in one plane. Now what we are going to do now, we will take this atom and we are going to place this atom over this another, over this atom again, like this. Okay, so for make it more clear, let me just reduce the size small. Smaller size I am reducing, just small, like this. Okay, like this. It is placing over the other. Okay, four layer in one plane, four layer in other plane, like this we are placing. Then what is this void is? This void is called as a cubical void. and coordination number we are seeing here is 8, and it is formed in SCC unit cell. SCC unit cell. Okay, let me show you also. If you remember SCC unit cell, where it is, yes, see, SCC unit cell, this void is a cubical void. So if you see the size of voids, so which is the greatest size? First is cubical void, then we have a like octahedral void, then we have a tetrahedral void, and then we have a triangular void. This is the order of the void. Okay, this is the biggest void. Cubical void is the biggest void we can have. All the voids are generally less than these voids. Okay, this is the biggest void we have. Okay, this is the biggest void we have. So basically in this class, what are the topics we have seen? We have seen the all the different types of packing. We have seen the all the different types of voids are there. Now in the next class we are going to basically see the different types of defects. We will see some, we will solve some problem also, and we will most probably I think one or two lectures maximum it needed to finish this chapter. This chapter will be finished. So after that we will move to the, like, after this, which chapter you want me to start? Like in, you tell me in the physical chemistry, which chapter you want me to start after this? Which chapter you want after solid state?
Any subject is okay, sir. Any lesson is okay.
No, like we have to, like, I want to finish first physical chemistry. I have told you also, like we will first finish physical, then organic, then we will move to the inorganic. So after finishing this solid state, which chapter you want me to start? You can tell me, I can go with that chapter also, no problem. Like if you have any preference, otherwise I can, like, I can start with the electrostat also if you want.
Okay, sir.
Electrostat, not sorry, electrochemistry. And electrostat will go up to, I think it will go for more than one more week. It will go, okay, it will go 2 3 weeks, because that is a very big chapter. I will teach 2 3 chapters within this electrostat. Potential and everything will be covered. So just start now. You can solve the DPP more questions. Till now you have solved that question, you can solve more questions now, because most of the part we, like, almost the chapter is finished. Only small, we have only left with the defects, type of defects. Now the chapter is almost over. Okay, that is a theory portion only. Okay, so you can solve all the problems. This class is how much? Like, what is the timing of this class? Do you know?
So 4 to 7.
Okay, okay, 4 to 7. But like, I am ending this class right now because I have some work, and so sorry for morning. Like I was not able to get up, so that's why I'm not able to take the class. But tomorrow I will take the class in the morning. We will having a physics class from 5:30 to 7, and tomorrow we will have a evening, like evening same types, same time the classes will be going on from 5:30 to 7. Okay, and okay, 1 minute. There is some doubt is there. Explain cubical void again. It's cubical void, like, simple cubic unit cell. In simple cubic unit cell, the atoms are placed at the corners. Okay. So if you take the corner atoms, suppose this four corner and this four corner atom, and this join this, whatever the gap you get, na, that is called as a simple cubic. Have you present in this class? Are you present in this class when I had taught this thing? This type of unit cell I taught. That time you are not present, I guess, right? Are you present there? But I haven't seen you there. See, in this simple, we are placing a four atoms in one plane, and then we are placing another four atom above to it. So if you place four, and it is a sphere, it is not a disk, it is a sphere. We have four atoms, we are placing a four more atoms. So in between you will get some gap, right? This gap. This is called as a cubical void, and that is what I have shown there. It's a cubical void. Okay, we are placing a four atoms, and then we are placing another four atom over it. So it will form a cubical void. Okay, I haven't seen you earlier. You are like you. Today is your first day. What is your name? Varun Hari. Three some bug in Zoom, sir. There is some bug in Zoom. I don't get this. Like generally, Zoom don't have any type of bug. What type of bugs you have in Zoom? I haven't know that there is any bug in Zoom right now. But okay, if you are saying maybe there, I don't know about this. Like try to be regular in the class because I am seeing you first time only. Okay, try to be regular in the class. If you are not regular in the class, then it is like be a problem for you. Okay, because see, right now we are going little slow because I want to complete first chapter properly. After that, my speed will be increase because you have to be familiar with me, I have to be familiar with you. Once everything, when this thing will be happen na, after that you would like this chapter will, the syllabus will go like this. It doesn't mean that you won't understand anything, you will understand each and everything, but my speed will be very fast. Okay, just I'm taking time for the first chapter. Okay, after one, let me just finish this first. Okay, one more thing, like have you completed the vectors? Have you completed the vectors, senorita?
No,
Yeah.
sir.
Okay, you haven't seen the lectures.
Yes, sir.
Okay, okay. Like just try to see it so that you can complete the vectors because vectors is very important. Okay. Otherwise, it will be a problem for you. Okay. Otherwise,
Okay, sir.
just try to complete it. Okay, as soon as possible.